Looking at yesterday's work, we started by looking at our very basic parabola, which we referred to as a quadratic function. So there's a couple things about that. Quadratic means that when you write out the equation, the highest degree of the equation is 2, meaning that you've got an x squared value. Okay? Really amusing. Right, you're amusing yourself. Would you like to eat it? Okay, so I got y equals x squared. So we talked about a couple properties. First of all was the vertex. What's the vertex of this graph?
0, 0.
0 and 0. It's a coordinate, right? So we need an actual coordinate value. Okay? The vertex tells us a few things. What are some of the things that the vertex tells us? The minimum or maximum, right? So if it opens up, it's a minimum value, correct? Okay? If it opens down, it's a maximum value. What else does it tell us?
Where the line of symmetry is.
Where the axis of symmetry is. That's the line that divides it into 2 equal parts. So we refer to that as our axis of symmetry, and it's an imaginary line. Okay? So the axis of symmetry, what is the equation of the axis of symmetry?
X equals 0.
Very good. X equals 0, and we get the 0 from which part of the coordinate?
The x value.
The x value of the coordinate, right? Okay, and what else did we get from that vertex? We're missing one thing.
Oh, domain and range.
Yes, very good. Okay, what is the domain for this graph?
Yeah.
X an element of all reals, because it goes left forever, right forever, right? And then the range for this graph was y is greater than or equal to 0, or y is an element of all reals, because the lowest possible value is right there and it opens up. So that's what we did yesterday, right? That was okay so far? All right, the standard equation for this graph was y equals ax squared plus bx plus c. Okay, now to begin with, what does the c tell us about the graph? Y-intercept, very good. What does the a tell us about the graph? That's the one we wanted to focus on.
And how wide.
Okay, so how do we determine whether it opens up or down?
If it's positive, it opens up.
If it's positive a, it opens up. Yeah.
If it's negative, then it opens down.
Awesome.
And if it's a whole number, it's skinny, but if it's a decimal, it goes wide.
Awesome. Well said. Okay? If the a value is greater than 1, right, or larger than -1 or smaller than -1, it narrows your graph. Okay? Because it goes up faster, because you times or multiply all of the y values by that a value from your original graph. So that's great. And then the b value, what did it tell us? What did the b tell us?
Yeah.
Moved our vertex, and it either moved it left or right or up or down, depending on what the b value was. But in this actual form, we don't worry about it. All we need to be able to do is graph it, and then see where it moves from that point, from that original vertex, which is 0 and 0. Okay? Now, I also mentioned yesterday that the general equation for this graph was that, in which your a value still does the same things. It still tells you whether it opens up or down. It still tells you whether it's wide or narrow. But the h and k told us something else. What did the h and k tell us for our graph?
H is left or right, K is up or down.
Up or down. Okay? And what more specifically does h and k actually represent? No? Yes, it does, Sophia. Good. H and k actually, in this form, is your vertex. Okay, so we showed that yesterday by doing this. Graphing y equals x squared. Okay, in which my vertex for this one was 0, 0, right? And then I'm gonna go y is equal to okay, so I have x minus 2 squared, add 2. So which way does my vertex move?
Left, right, 2, and up.
Right 2 and up 2. We agree?
Yes.
So
One,
if it's a
two,
negative number, it
one.
moves right.
2. Okay, so we're gonna talk about that in a second. Okay? So my now vertex is my h value. What's my h value in here? Plus 2. What is my k value? It's the value out here, which is also plus 2. Okay, so,
Isn't the
nope. So I'm going to explain that right now. Okay, so in this form, when it's a subtract in the brackets, that means that you are actually subtracting a positive number. You're subtracting plus 2. And plus 2 moves it to the right. If I have an add in the brackets, I'm actually subtracting a negative number, which then means it moves to the left. That's why it's opposite. So if I have this,
So that's actually -1 in the bracket.
that's actually a -1 in the brackets. So what is my vertex from this graph then?
Left.
What's my vertex?
-1 and 3.
Oh, yeah.
-1 and
3.
-3.
very good, Kelly. That's my vertex. So when it's an add in the brackets, now this is massively important to you. Because when we go through this in pre-calculus, especially in grade 12, we are going to do this all the time, in which that is an opposite move than what you think it is because of the sign. Okay? It always happens like that if it's inside the brackets and it's a subtract, that means you're subtracting a positive number. If you're adding, it means you're subtracting a negative number. Only inside the brackets of any function that you're going to look at, ever, does it work like this. Okay, now I'll just show you. You don't need to know anything about this, but I'll show you what I mean as to how come it works, or why it works, or not necessarily why, but how it works for every other function. Y is equal to the square root x. Now just think about this for a second. If I put 0 in for x, what is y? What's the square root of 0? 0. What's the square root of 1? What's the square root of 4? Square root of 9? 3. So this graph actually looks like this. So you can't have a negative number, correct? You can't have the square root of a negative number, right? Okay, so now y is equal to the square root of x subtract 2. So with what I said to you, what direction do you think this is going to move?
To the right, up. Well, to the right at least.
To the right at least?
Yeah.
I'd say to the right at most. There's no vertical change here. There's only one move. And that is to the right. So I would move this guy. So instead of this being 0 and 0, it becomes 2 and 0. And this whole graph moves over that way. 2 to the right. Okay? But there's no brackets here. Well, the brackets are assumed inside the square root. Okay? Let me show you another one. Because there are 5 graphs in which when we start grade 12 pre-calculus, there's 5 graphs. I'll show them to you in grade 11 pre-calc too. But when there's 5 graphs that we have to just know how to sketch the moment we see them. This is one of them. The parabola is a second. Cubic function, y equals x cubed is a third. This one. This is another one that looks exactly like it. Or we have to be able to know how to graph, and that's this. Y equals the absolute value of x. Okay, we haven't talked about absolute value much. Okay, but the absolute value. So what does that mean? That means that I turn every negative number into a positive number. Okay, I'll explain all the rationale when we get to grade 11 pre-calc for those that are in it. So minus 4 becomes plus 4. Minus 2 becomes plus 2. Because they are the maximum distance, those are the actual distance they are from 0. So what does that graph look like? It looks like this. Because if I put 1 in here, what's the y value? It's 1. And I put 2 in here, what's the y value? 2. 3 in there, 3, 4, so on, right? Okay, negative 1 in there,
1,
plus 1. Negative 2 in there,
2,
plus 2, negative 3 in there.
3.
So this is what it looks like, right? So it goes up like that. Okay? So now what happens, okay, and I would refer to this as my vertex as well. Because a vertex is just a coordinate where the graph changes its direction, so to speak. All right? So it's very similar to a parabola like the way I've drawn it. It just doesn't go rounded up, it goes straight up. Okay? So then, what happens here? Which way does it move? Is it in the brackets? Okay, if I consider the absolute value actually as brackets, which I should, it's in the brackets, so which way is this going to move then?
Right.
To the right one. So all of these graphs all work the exact same way. And in fact, we spend all of grade 12 pre-calculus using these to help us graph without calculators. Just using this very basic principle as to phase shift, left and right, and up and down shifts for the most complicated graphs you can think of, but they all work the exact same way. Once you get them into their general form, they all move the exact same way. Okay, so if I did, for instance, I did y equals sine x. There's a graph that we look at next year in grade 12. Y equals sine x looks like this. There's y equals sine x. Now, it's not going to make much sense to you because we haven't seen any of this. But if I move it, which way am I moving my sine x graph? 90 degrees to the right. Okay, so how does that look? Well, that comes right to here, here, there, there, and there, and then down here. So I've moved this coordinate right here that way, 90 degrees. Okay, again, same principle as with the parabola, as with the square root, as with the absolute value. By placing it inside the brackets, that just tells me whether I move it left or right. Okay? So, what our ideal situation is, I'm going to just find an equation here that I can work with. Where do I look? Sorry, I want to find it. Here it is. Okay, so here's what we're working with. Okay, so I look at that equation right now. So this is Monday next week, or probably Tuesday next week. Okay, so I'm looking at that equation right now. And right now I'm telling you, you use your calculator and you graph it. Okay, that's perfectly exactly what we want to do. Okay, so we're going to graph that. But there's got to be a way in which I can do this without graphing it. And this is what we're going to work towards doing. So we get these steps. It's called completing the square. So what I want to do is I want to find out what my vertex is, which way it opens, and all of that without having to write it in or punch it into a calculator. Okay, so to do that, I do a process here. I put brackets there. I factor this out. And again, this is not going to make any sense to you yet. Okay, so it's a whole long process, but what I'm gonna do is I'm gonna convert it from that ax squared plus bx plus c into ax minus h squared plus k. And then from there I can graph it easily. So I take half of that number and I square it. So it looks like this. So I go minus 2, x plus 4 squared plus 32 plus 42. All right. So now this equation right here that I started with becomes this. At this point now, what's my vertex?
4 and 42. Negative 4 and 42.
Awesome. There's my vertex. I got that from there without having to use my calculator and finding it. Okay? So that's exactly what I'm going to end up with. Does this graph open up or down? Up? Sophia, you're shaking your head. Do you have any idea?
Opens down.
How come it opens down, Sophia?
Because if you look back up at the normal thing you got, equation, thank you, it's a -2.
Negative 2. What's a negative 2?
8.
A.
Oh.
This does open down. I don't have to look up here, Sophia. I can look right there. That's still my A. A, x minus h squared plus k. So she's right. A is a negative number. That means the graph opens down. Okay, and that's what we did need to know from yesterday. Okay, so all of this is still, this is 2 days from now, but the rest of it is yesterday's work. Okay, the axis of symmetry, the vertex, being able to graph it, does it open up or down, all of those, okay, is yesterday's work. What is today's work? Today's work, we're going to look at a standard equation. We're going to graph that standard equation, and we're going to find what we call the roots. The roots of the equation. Okay? Does anybody know what the roots of an equation are?
Where it crosses the x-axis.
Well done. What else do we call those roots? Well done. So there, we've got roots and x-intercepts. They're the same thing. There's a third word for it. Anybody know what the third word for it is? Z. Everybody help? Zebras? Here we go. Yeah, that's it. X-intercepts, roots, and zebras.
Yes.
It's to throw off people.
Sounds about right. Sounds about right.
I
Okay.
mean, it makes much sense.
Tucson, Casey, Tucson.
These cases.
Okay. The reason I'm telling you what the third is, because when you use your calculator, you need to know what the third one is, because that's how you look for it. Okay? Roots, x-intercepts, not zebras, zeros.
That was like
Yeah, that's three.
it's not.
That's three Cheerios.
He's calling. He's asking people.
Speechless. Kids these days. Okay. When I look at the problem, how many roots is it possible for me to have?
Two.
Two's the most I can have, right? Is it possible for me to have less than 2?
Yes.
How many?
You can have one.
You have 0.
I could have 1, or I could have 0. That's right. I could have 0, 1, or 2 roots. Okay? Because the graph could be moved up and open up, therefore it would never touch the x-axis. So that would be your 0 roots. Right? 1 root would be like our standard graph in which the vertex is on that axis. Correct? That would be 1 root. And then finally, you could have 2 roots if the vertex is above the axis or below the axis, and then it opens the opposite direction. Okay? So 0, 1, or 2. Now on your calculators, for those that have them, okay, you have to find, use second function trace, which is calculate, and then you're looking for 0 to find it. Okay? So that's what you need for the graphing calculator. Right now, they are not asking you to solve these. Or are they?
Says estimate.
Yeah, no, we don't estimate anything. We find it. Okay. So let's look at page 188, please. I want to look at 188, and I'm going to look at this one question, which is question 4 on 188. Okay? I have two graphs given to me. F of x is equal to
3.5x squared plus 2x minus 2.1.
Thank you. And what's the next equation?
Gx in brackets equals, oh wait, no,
Yeah, you're right.
6x bracket 3 minus x. 6x, yeah,
Bracket.
3 minus x.
That?
Bracket.
Okay. So what do I have here? I have two equations. First is a quadratic equation. The second is also a quadratic equation. Doesn't look like a quadratic equation because I have two x's, but what I actually should do is multiply that 6x through the brackets. And then what would happen? Well, 6x times 3, 18x, minus 6x squared. So what do I have here and what am I looking for? Well, I have two parabolas, all right? And they want us to graph the two parabolas and then find where they intersect each other. So there's two methods in which you could do this question. The first method is to graph each of these individually and just find your intersection points. That's probably the easiest for you to do. Okay? So we graph one, graph the other, find the intersection points using second function trace. Fair enough? Okay? The second way to do this would be to get them both to the same side and equal 0, and then simplify it and find your zeros. But we're not there yet. We don't want to worry about that. Let's just practice graphing. Okay? So what we're going to do then, right now, is I'm going to graph both of these. And then let's find the intersection point of both of them. So I have y equals, okay, what's the first one? 3.5
X squared
x squared
plus 2x
plus 2x
minus 2.1.
2.1. Enter. Okay, thank you. What's the next one?
6x bracket 3 minus x.
Right. 3 minus x bracket. Enter. Okay. Okay, so I have two parabolas. First parabola is right here, opens up. Second parabola is this guy that opens down. And now I would want to find that point right there and that point right there. Okay, so on your calculator you would use your second function trace and calculate. On this bad boy here, I could, oh, I'm going to get this off here. Let's go options, find intersection, calculate, and there they are. Okay, so the two calculation points, it's hard to read right here, are this guy right here is, I'll write it down. guy up here is 1.8066 and 12.9361. Okay? There's your two intersection points. Okay? And you can graph that by putting one as y1 and one as y2 and find your intersection using your second function calculator on your calculator. Alright? Okay, so today, I don't imagine most of you got through 7.2. There's quite a few graphs that you're supposed to graph on there. So you have 7.2 and 7.3 to work on until Monday. Okay, any other questions? Any questions about